In this video, we demonstrate how to measure the displayed average noise level, or DANL, with the Spectran V6 Eco. To begin, a preamplifier is installed in the V6 Eco unit. That is important for achieving the best performance. The Spectran V6 Eco block is added from the measurement blocks panel on the left. Next, search for IQ and add the IQ power spectrum block. It connects automatically. Then search for Spectrum and add the Spectrum display block. That completes the basic setup for this short demonstration. Leave the default center frequency at 2.44 GHz for now. Also note that a 50 ohm termination is connected to the RF input. For the most accurate noise measurements, a shielded chamber is normally preferred to avoid unwanted leakage. Now, set the center frequency to 1 GHz. Type 1 and select gigahertz in the center channel field of the Spectran V6 Eco block. Start the measurement by clicking the green Start button in the ribbon bar. The real-time spectrum scanning begins, and the current noise floor performance becomes visible. Select half from the span dropdown in the Spectran V6 Eco block to narrow the display. Then open the spectrum block configuration by clicking its gear icon in the work graph. Go to the View tab and scroll down to the Markers section. Enable Marker Table View so marker details appear in a table. Some default traces are not needed for this measurement. In the trace legend, right-click the Max Hold trace and remove it. Then right-click the Clear Right trace and remove that as well. Only the yellow average trace remains. At this point, the marker on the average noise floor shows about minus 90 dBm. To improve the noise floor, adjust the reference level. Change the reference level in the Spectran V6 Eco block to minus 55 dBm. This activates the preamplifier. The preamplifier is essential for achieving a lower noise floor. A quick check in Device Manager confirms that the preamplifier option is enabled for this V6 Eco. With the preamplifier active, the noise floor drops to around minus 128 dBm. Now compare this real-time analyzer performance to a typical swept spectrum analyzer. Add a new marker in the spectrum block configuration by clicking Add in the Markers panel. Change Marker 0 from Peak to Spectral Density. The marker now displays a spectral density of about minus 171.4 dBm per hertz. The power level at the marker is about minus 128 dBm. To compare against a swept spectrum measurement, adjust the resolution bandwidth. In the IQ Power Spectrum block configuration, under the main tab, change the RBW to 100 kHz. With 100 kHz RBW, the average noise floor shown by the marker is about minus 121 dBm. That confirms the very good performance of the V6 Eco. Now explore lower RBW settings. In the IQ Power Spectrum block configuration, change the FFT length to 512. Then set the RBW to 1 Hz. To speed up the display, open the Spectrum block configuration and change Average Sampler to 146. Click Stop to pause the current sweep. The marker on the average trace now shows a noise floor of around minus 170 dBm. Next, set the RBW to 10 Hz. Before starting the new sweep, save the current 1 Hz RBW trace as a reference. Right-click the average trace in the trace legend and select Add to Reference. Rename the trace to 1 Hz. To make the label visible, set Show Name to above left in the remote config panel for that trace. Start the sweep again. A yellow average trace now appears for 10 Hz RBW, compared with the blue 1 Hz reference trace. The expected 10 dB noise floor difference is clearly visible. Save the 10 Hz average trace as another reference. Right-click the average trace and select Add to Reference. Rename the new reference trace to 10 Hz. Set Show Name to inside left in the remote config panel for that trace. Now change the RBW to 100 kHz. Start the sweep again. The yellow average trace now shows another 10 dB increase in the noise floor relative to the previous 10 Hz reference trace. This demonstrates the consistent change in noise floor as RBW changes. At 100 kHz RBW, the average noise floor is around minus 150 dBm. Continue the same process for additional RBW values. Set the RBW to 1 kHz. Set the span to half. Start and stop the sweep. The noise floor is around minus 141 dBm. To declutter the display, remove the older reference traces. Right-click the 1 Hz RBW trace and remove it. Right-click the 10 Hz RBW trace and remove it as well. Zoom back to full span. Add the current 1 kHz average trace as a new reference. Right-click the average trace and select Add to Reference. Rename it to 1 kHz. Then set the RBW to 10 kHz. Start and stop the sweep. Add that average trace as another reference and rename it to 10 kHz. Finally, set the RBW to 1 MHz. Start and stop the sweep. Now, the differences between the 1 kHz, 10 kHz, and 1 MHz RBW traces are clearly visible on the display. The labels can be made visible in the remote config panel by choosing appropriate show name positions such as above center or inside left. The 1 MHz RBW trace shows a noise floor of about minus 111 dBm. The key takeaway is that a clear 10 dB step appears in the noise floor as the RBW changes from 1 MHz to 100 kHz to 10 kHz and to 1 kHz. This concludes the quick introduction to measuring DANL with the V6 Eco, the IQ Power Spectrum block, and the Spectrum block. For more information, check out our other videos on our YouTube page or visit aroniausa.com. And if you have ideas for other videos you'd like to see, leave us a comment below.